All right, so last time we left off talking about law of cosines, and I wanted to do one example problem for you, and you guys have already sort of practiced on a few of those as you've taken a look at your homework in this section too, I know. But Clint is building a wooden swing set for his children. Each supporting end of the swing set is to be an A-frame, constructed with two 10-foot long 4x4s joined at a 45-degree angle. Okay, so there's some construction stuff in here, and for those of you who have experience with that, you're one up on me. But the picture that you need to have in your mind is that the end of the swing set looks like an A. Okay? So the part that tells about being important is the fact that the two lengths of your, let me use this one. The two lengths of the pieces holding the A together are each 10 feet. So this is the image that we have to start with. And yes, it probably has a beam across here like this. Maybe it doesn't really matter. That's not part of the problem that we're dealing with. And the fact that it says that they're 4x4s is just describing the type of wood that we're looking at too. So that doesn't affect my particular problem either. All right. The part that's important is that I have two beams that are 10 feet long that are going to be bracing this swing set. It says to prevent tipping, oh, and they're joined at a 45-degree angle. That's important as well. Let's put that 45-degree angle here at the top.
So can you assume that the angles at the bottom are equal?
They are equal. Do you remember why?
Because if you have two congruent sides, that's right.
Right, and that was a feature that you probably encountered in a geometry class talking about isosceles triangles. So if isosceles triangle has two congruent sides that are the same, two sides that are the same, they're congruent, then the base angles are the same as well. So yes, that is correct. We actually know the two bottom angles of this triangle as well. They would be what? Did you find it for them?
67.5.
Okay, so they're 67.5. All right. I'm not sure that we're going to need that information at the moment, but you could use that information if you wanted to when you're solving the problem. That certainly would be a reasonable thing to do. Now it says to prevent tipping, Clint wants to secure the base of each A-frame with concrete footing. How far apart should the footings be for the A-frame? So we actually are going to create, I don't know, some kind of a concrete underground, right, that holds this still. My husband had to do this when our trampoline blew away a couple years ago. He had to do something that actually braced it to the ground so that it doesn't blow away. That's what Clint's going to do here. He's going to brace this to the ground so his kids don't fall on their head. Sounds like a good plan to me. And what we want to know is how far these are apart. So in other words, we actually want to know this distance down here at the bottom. And you can call it whatever you'd like. I'm just going to call it X for the purposes of what we're working with, and we'll call X. Okay, is everybody good? All right. So this is law of cosine, and the reason it is because I have side, interior angle, opposite side. Or sorry, the other side. Okay, the two sides are surrounding my angle. And the one that I'm wanting to find the information about is opposite the angle that I'm looking at. So I don't care which one you call it, but I actually have the one where I have the angle 45 degrees, and I don't have the side x. So this is x squared equals. We have sides A and B, if you will, if you want to call this A and this B. That's not good because I called it A at the top. We call this A down here. This one B and C. Then we have 10 squared for B squared plus 10 squared for C squared minus 2 times 10 times 10. And then it's the cosine of 45 degrees. Okay, is that good to everybody so far? So this is one of the ones we dealt with. It's the easier of the two options because everything on the right-hand side of the equation is known. I have numbers in there for everything, right? So your calculator can handle this just fine if you enter it straight in there, most of your calculators anyway, as long as you're being careful about your parentheses, and of course you have everything in degree mode, okay? So if you 10 square and 10 square, you're going to get 100 squared twice, or 100 twice. And then if you do 2 times 10 times 10, that's 200 cosine 45. Again, you don't have to do that. Your calculator will do it for you, but once we add everything and subtract and do the cosine and whatnot, what do you get on the right-hand side before you square root? 58.58. Caitlin, can you give me 4 decimals instead?
58.5786.
Okay. I just want to make sure we don't lose accuracy before we actually square root. We will do the 2 decimals when we're done with our square root, though. All right, so we're going to square root. So what do we get for x? 7.65 what? Feet. That happened on your test, too. Some of you forgot measurement units, either degree measurements or feet or something like that, feet or something like that. So we actually get that it's 7.65 feet apart. Now, pause for a moment and make sure that makes sense. So Alex just told us that these base angles, what were they, Alex, 67.5? Okay. These are 67.5.
You get the same thing when you do sine?
Yes. So these two right here at 67.5, right there, they are the angles that are opposite the sides of 10 feet, right? So the fact that I got 7.65 feet down here is reasonable because it's opposite an angle that's smaller. If I had gotten a value down here on the bottom that was 13 point something feet, I would have cause for concern. That can't be right because the opposite angle, 45, should be a smaller side than the 10 feet. Is everybody tracking with me on that? Make sense? Okay, and so Alex makes a good comment too. If we stop for a moment and consider that we have the 65.5 degrees on the bottom, we could use law of sines on this, couldn't we? You bet we could, because we happen to have an isosceles triangle that we've got the base angles for. So you could set this up with law of sines, and you would do 45 degrees over the angle I want, the side I want, which I called A, and it equals sine of 67.5 degrees over 10, no matter which pair of angles you find. And you could use law of sines to find this, right? And you checked it for it, right? You said it gave us the same value? Did you try it this way? And it gave us the same value. That's good to hear, right? We definitely want to have the same value or we've got some sort of other issues going on. Any questions on this one? All right.